is Rowell, and welcome to our class. Our topic for today is finding the nth term of the arithmetic sequence. Let's study the illustration below. So how did each column increase with rectangles? So we have on the first column, we have one rectangle. On the second column, we have three rectangles. On the third column, we have five rectangles. In the fourth column, we have seven rectangles. Now, how many rectangles will there be on the 25th? Can you give me the answer? What about how many rectangles will there be on the 100th? Okay, so let us find the general nth term of an arithmetic sequence. So let's consider the sequence 4, 7, 10, 13, 16, 19, 22, 25, 28, 31, and so on. So let's write it in a table. So the first row is the number of terms, and the second row is or are the terms of the given sequence. So first term is 4, second term is 7, third term is 10, fourth term is 13, and so on. Now let's rewrite our table. So we have a sub 1, the first term is 4, until a sub 8, which is 25. And we don't know the number or the number in our a sub n. So this is our nth term of the sequence. Okay, so in the third row, we rewrite our terms in the second row. Okay, so we have, on the first term, we have 4. Kopyahin na natin. And the second term, so in order to get 7, we add 3. Right? And the third term, in order to get 10, we add 7, another 3. So that is 4 plus 3 plus 3. And for the fourth term, to get 13, we add another 3. And so on. Okay, now we are going to rewrite again our sequence. On the first term, we still have the first term a sub 1, no changes. On the second term, we rewrite it as 4 plus 1 times 3 because there is only one 3 in the previous row. Now for the third term, we have 2 times 3 because there are two 3's in our sequence. In the fourth column or fourth term, we have 3 times 3 because there are 3 terms in 3 3's in the second row. And on the fifth term, we have 4 plus 4 times 3 because there are 4 3's in our sequence. Okay, can you write the eighth term? Okay. Now on the fourth term, the fourth row, we rewrite the sequence in more general term. Okay, so for our 4, let us write it as a sub 1 or the first term. So on the second term, we have a sub 1 plus d. So let us assume that 3 is d. Okay, so 1 times d is d. Now on the third column, we have 2 times d. So we assume, or we set 3 to d. So we have 2d. And then we have 3 times d, 4 times d. copy the first term. There is no changes in the first term. So can you now write the nth term? Okay, so let us put it this way. So what is the relationship of the numerical coefficient of n and the subscript of a? So how did you what is the relationship between the coefficient of d? So this is the coefficients, the number beside the letter. The coefficient of d and the subscript, the number below the letter a. What is their relationship? So let us think of this way. So for the first term, the same. For the second term, so we have 1, the coefficient of d, and the subscript of a is 2. For the third term, the coefficient of d is 2, the subscript of a is 3. For the fourth term, the numerical coefficient of d is 3, and the subscript of a is 4. For the fifth term, the numerical coefficient of d is 4 and the subscript of a is 5. So, what is the relationship between 4 and 5? How did we obtain 4 and 5? So, let's have this. The numerical coefficient of d is less than 1 of the subscript of a. So, it means that the numerical coefficient of d is just minus 1 of the subscript of a. So we have for our n, we have n minus 1. So therefore the nth term of an arithmetic sequence is a sub 1 plus the product of the quantity n minus 1 times d, where a sub 1 is the first term, d is the common difference, n is the number of terms. So the common difference is explained in the previous video. Okay, so let's take an example. So consider the arithmetic sequence 4, 7, 10, 13, 16, and so on. Find the 100th term of the sequence. So solution. So for our n, that is 100. So there are 100 terms. And for first term is 4. Then the common difference is obtained by the second term minus the first term. Or we can also get it by the third term minus the second term. So for this example, we have 7 minus 4, first term minus the first term, 7 minus 4, that's equal to 3. Now let us use the formula for the nth term of our sequence. Then substitute the known values in the formula. That is, so our n is 100, a sub n is 100. For the first term is 4, our n is 100, and d is 3. So these are the values obtained in the given. So simplifying, we have 4 plus 99 times 3. Then 4 plus 297. So simplifying, we have the 100th term of the given sequence is 301. Okay, example number 2. Consider the arithmetic sequence, negative 15, negative 7, 1, 9, 17, and so on. So find the 50th term of the sequence. So for our solution, n is equal to 50. The first term is negative 15. For the common difference, we have the first term minus the second term. So we have negative 7 minus the first term of negative 15. So negative times negative is positive. Negative 7 plus 15 is positive 8. Now use the formula and substitute the known values in the formula. That is, so we have here, replace natin yung n as 50. Replace natin yung a sub 1 ng negative 15. So ang n is 50 minus 1. Replace natin ang d with 8. So simplifying, we have negative 15 plus 49 times 8. So negative 15 plus 392, and so the 50th term of the given sequence is 377. Example number 3. Consider the arithmetic sequence -5, 1, -3, -7. So find the 75th term of the sequence. So our n is 75. Our first term is 9. And the common difference is second term minus the first term. So 5 minus 9. So we have -4 as our d. So substituting, we have a 75. 875 is equal to the first term 9 plus 75, that's n minus 1 times the common difference of -4. So we have 9 plus 74 times -4. So we have 9 minus 296. So we have -200. The correct answer must be -287. It's just a typo error. So -287. Okay, so let's proceed with the exercises. So you may pause the video to copy the problem. And don't forget to like this video and subscribe. Thank you for watching.